Hi, this is Mr. O'Neill. We're going to review the Motion and Forces Study Guide. First question, what is a distance? How far you moved the SI unit is International System Units. Unit for distance is the meter. It's abbreviated lowercase m. What does a distance time graph show? It shows the distance over time. So what is speed? Speed is equal to your distance divided by your time. It's abbreviated lowercase s is equal to d over t. What is the SI unit for a distance? It is a meter per second. So there are two ways to describe speed. The first is your average speed. To describe it, that is the total distance that you traveled over the total time that it took. The second kind of speed is called instantaneous. That is the distance, the speed at a given moment. What is velocity? Velocity is speed plus your direction. The SI unit for velocity is the same as speed. It's meters per second. The difference is that it has a direction to it. Next question, what is acceleration? Acceleration is the change in your velocity over time. When we measure change in science, we use final minus initial. We also abbreviate it sometimes with the Greek letter delta. Delta V over time. The SI unit for acceleration is meters per second, which is also known as meters per second squared. Acceleration can be positive or negative. If your final velocity is higher, you are speeding up, and your acceleration is positive. If your final velocity is lower, you are slowing down, and that means your acceleration is negative. When an object's accelerating, it can do one of three things. The three things are speeding up, slowing down, or changing direction. What is a force? A force is a push or a pull. A force causes acceleration. Or some kind of change. When an unbalanced force acts on an object, it causes acceleration. According to Newton's second law. International System of Units unit for a force is a Newton. It's abbreviated capital N, and it's equal to 1 kilogram times 1 meter per second squared. Newton's first law of motion is the law of inertia, which means that an object resists a change in motion. If an object is at rest, it wants to stay at rest. If it's moving, it wants to resist any change of speed or direction. Inertia is a tendency of an object to resist a change in motion. Newton's second law states that the acceleration of an object is directly proportional to the force and inversely proportional to the object's mass. It's commonly stated as a formula, F equals ma. Two things affect the acceleration of an object. One is the force applied, particularly unbalanced forces. The second is the object's mass. The units for Newton's second law, for force it is the Newton, for acceleration is meters per second squared, and for mass is the kilogram. Newton's third law of motion states that for every action there's an equal and opposite reaction. Examples of reaction forces include a car wreck. So as you get in a car wreck, your body tends to stay in motion unless it's restrained by a seat belt or opposed by an airbag. There's also the example of a canoe. When you're stepping off the canoe onto a pier, the canoe gets pushed backwards as you move forward. Another example is a rocket. When you burn a rocket, the force of the gas is going out the bottom of the rocket causes the rocket to experience an equal and opposite force to go up to the sky. Here's an example of a math problem. So once we know the force, we know that according to Newton's law, force is equal to mass times acceleration. In this case, it's 0.145 kilograms for the mass. And the acceleration is 25 meters per second squared. Gonna need a calculator. You take 0.145 times 25. It's 3.625 newtons. Here's another example. You want to know the force. Again, mass times acceleration. The mass in this case is 0.003 kilograms. Acceleration is 400 meters per second squared. Take your calculator, 400 times 0.003. That's equal to 1.2 newtons. Here they want to know the acceleration. So So acceleration is gonna be equal to force divided by mass. The force in this case is 1.5 newtons. And divide by the mass of 4.5 kilograms. Since a newton is a kilogram meter per second squared, the kilograms cancel out and you're left with meters per second squared. The number that goes with that is 0.33. Just round off to 2 decimal places. The units are meter per second squared. Next problem, they know the car's speed and they want to know the acceleration. So we know that acceleration is the change in speed divided by time, which is the final velocity minus the initial velocity divided by time. In this case, I'm going from, that's the initial, to, that's the final. So 65 meters per second minus 40 meters per second. Time in this case is 20 seconds. So I take 65 minus 40, gives me 25 divided by 20. And I have 1.25. The units are going to be meters per second, or meters per second squared. Here's an example, they want to know the speed. We know the speed is equal to distance divided by time. So the distance is 60 kilometers. Kilometer is 1,000 meters in 35 minutes. We could easily just put the kilometers, give the answer in kilometers per minute. Take 60 divided by 35, gives you 1.71 kilometers per minute. If you choose different units, the answer will vary. Tow truck exerts an external force or horizontal force of 1125 newtons on a car. What's the acceleration? We know that acceleration will be equal to force divided by the mass. The force in this case is 1125 newtons. The mass in this case is 825 kilograms. Again with the calculator, 1125 divided by 825 is equal to 1.36 newtons. Excuse me, meters per second squared. Next question. We're done. So that is the answers to the study guide. Hopefully you got the same thing.